So question 14 says, find the complex zeros of the following polynomial function and then write in factored form. So one way to try to do this is using the apps button. So if we go to the apps button, we know there's got to be 3 zeros. So number 7. So it is a degree 3, a plus bi. It looks good. So if I hit next, 1 there, minus sign, that needs to change to a 9. Plus sign, that looks good. 31. Minus sign looks good. 39. Again, you may have to identify yours as a sub 3, a sub 2, a sub 1, and a sub 0. Again, those are just the coefficients of the variables. So a sub 3 is the coefficient of x cubed, which would be 1. A sub 2 would be -9. A sub 1 would be 31. And a sub 0 would be -39. So if we solve this, so notice how it solves above graph, I hit graph, and it gives me 3, 3 plus 2i, and 3 minus 2i. So it did give me all 3 zeros. So it gave me 3 plus 2i, and 3 minus 2i. So it works just like that. We're done. But if we want to kind of see some other strategies, if I type y equals, let's see, y equals, and we have to quit this to start with. Yours may be different there. So if I type in y equals, if I type in this function, x cubed minus 9x squared plus 31x minus 39. So if I go to my table, I'm looking for a 0, and notice how there is a 0 there at 3. I don't really see any other ones here. A lot of times, if I just get 1 0, that's pretty much all I really need. So that's how that gives me the 3. So if 3 is a 0, what I can do is use, I can also look at the graph to see if there's any other real zeros. So hit the graph button. It looks like there's only 1 0 that's real. The other two are probably going to be complex. So that's something you can kind of do is look at your graph to see if I need to look anymore. But it only looks like there's only one x-intercept, which means there's only 1 0 there. So what I can do, though, is use synthetic division and divide the 3 into the polynomial. So just use the coefficients, though. 1, -9, 31, and -39. So remember, when you use synthetic division, give yourself a little bit of room. This 1 drops down. And then I multiply. 3 times 1 is 3. Add -6. 3 times -6 is -18. 31 and a -18, I believe that's going to be a positive 13. I need to check myself there. 31 minus 18. Since the signs are different, you subtract. Keep the sign of the larger one. 13. And 3 times 13 would be 39. So my remainder is 0. That's what we want, because if we're saying it's a 0, then it's also a factor. So what I can do then is, since it was a degree 3, this now becomes the quotient is going to become a degree 2. X squared minus 6x plus 13 is equal to 0. So again, if we want to solve this using the quadratic formula, we can find the remaining zeros. A equals 1, B equals -6, and C equals 13. So we have x equals, then the opposite of -6 is a 6, plus or minus the square root of. And then we have -6 squared, which is 36, minus 4 times A, which is 1, times C, which is 13. This is going to be all over 2A, or 2 times 1 is 2. So again, notice that 4 times 1 is 13, and 4 times 1 is 4. 4 times 13 is 52. 36 minus 52 would be a -16, I believe. If we just double check the math here, 36 minus 4 times 1 times 13, that does give us this -16. This problem looks kind of familiar. So 6 plus or minus the square root of -16 divided by 2. Remember, since there's a negative side of the radical, that has to come out as an I, imaginary. 6 plus or minus I squared 16 over 2. But the square 16 is 4. So this turns into x equals 6 plus or minus 4i over 2. And then if you divide the numerator both by the 2, 2 goes in 6 3 times, plus or minus, and 2 does go into 4i, and that gives me a 2i. So 3 plus or minus 2i. So we do get those zeros there that we're talking about. Now to write this in factored form, so this is where it gets tricky. So remember our zeros are x equals 3, and then we had x equals 3 plus 2i, and we had x equals 3 minus 2i. So if I set these all back to 0, that puts them back into factor form. So remember, when they come back across, the signs change. So x minus 3 is going to be called the factor when you set it equal to 0. If you move these back over, the signs change. X minus 3 minus 2i is equal to 0. So x minus 3 minus 2i becomes a 0. And then x minus 3 plus 2i equals 0. That's going to be my 3 factors. So if I put this in factored form, so where would that be at? And write in factored form. So where's my factored form at? So I don't see that anywhere as a question. So I'll just put it up here. So f of x is going to equal then this a times then, I think they assume the coefficient's 1. So I'm going to take the a out and just call it a 1. So we had x minus 3 was the first factor. And then we had x minus 3 minus 2i. X minus 3 minus 2i is the other factor. And then we had x minus 3 plus 2i. X minus 3 plus 2i. So that would be what it looks like in factored form. So the zeros have to be then put in the form of x minus r. So remember, all these signs have to switch when you do that. Okay.